Hello everyone. So we are going to solve this problem related to the mass attached to the spring. So let's say this is a spring and some mass is attached to it, and we drop this mass at time t is equal to 0, and the position of this mass is given by this function where x represents position below the equilibrium position, which is x equals to 0. So what is an equilibrium position? Equilibrium position is the position of the mass when it becomes stationary as t tends to infinity. So let's say if this is the position where mass becomes stationary when t tends to infinity, and we have x equals to 2, that means we are 2 units below the equilibrium position. And if x equals to -1, that means we are 1 unit above, the mass is 1 unit above the equilibrium position. So now assume that the mass begins moving at t equals to 0, then which of the following statement about mass is true? So let's try to plot this graph, because this function tells us about the position of the mass. So let's try to find out the zeros of this function. So we can do it by putting this function equals to 0. Then we will get 2e power minus t is equals to 3e power minus 4t. We can divide by e power minus 4t, then we will have e power 3t is equals to 3 by 2, and 3t is equals to log 3 by 2, and t is equals to 1 by 3 log 3 by 2. This is the thing. And now, so function is 0 at this point. Okay, so this is a positive value somewhere here, and then function is 0 when t tends to infinity, because if t tends to infinity, then both of these terms will tend to 0. So that means the graph of this function will be like, and when t is equals to 0, the x is -1. So we are starting somewhere from here, we are reaching here. Okay, but after one point the mass will stop going down, so it has to come back again. But then it approaches to 0 when t tends to infinity. So it is something like this. So this is the graph of the function, which tells us the position of the mass. So now we can read the given options one by one. So first is the mass will bounce up and down infinitely many times, each time with less high and less low. We can clearly see that mass goes down, then it comes up, but then it do not crosses the x-axis, and it do not oscillate up and down. So both options A and B are wrong, because mass, from the motion of the mass we can tell that it is not oscillating. Okay, it is just going down and then coming up back again to the equilibrium point. Okay, as t tends to infinity, mass approaches the equilibrium position from above the equilibrium position. So what is happening here? Let's say we drop this mass, so it goes down and then it comes back to the equilibrium position. So it is approaching towards the equilibrium position from below, from down. Okay, from the graph it appears that it is approaching towards the x equals to 0 from above, but but actually, because the positive values of x represents the position below the equilibrium position, so that's why it is approaching towards equilibrium position from below. So that means uh, D is correct, and C is incorrect. That is again because positive values of x tells us the how down is the mass, and when x increases, that means the mass is going down, and when x decreases, that means mass is going up. So that's why it approaches towards the equilibrium position from below. And since it is already true, E also cannot be true. So only option D is the true. Hence, so this is it for today, and thank you for watching.